Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
Right now, the smartest artificial entity on the planet lives inside this massive windowless concrete fortress.
Oh, yeah, like the size of 3 football fields.
Exactly. And it drinks enough electricity to power, a small city. It needs actual acres of roaring cooling fans just to keep from melting its own hardware.
It is basically the ultimate expression of massive centralized infrastructure.
Right. But here's the crazy part. Within a really short window of time, that exact same level of intelligence is going to be living inside your pocket.
Running on a battery the size of a matchbook.
It's wild. It completely upends our visual understanding of what a supercomputer is supposed to look like.
It really does. I mean, we've spent the last few years conditioned to believe that artificial intelligence is this, this behemoth living in a distant hyperscale data center.
Like it's a natural resource we have to mine far away from civilization.
Exactly. But today, we're going to completely flip that image on its head.
Welcome to the Deep Dive. Today is Friday, June 26, 2026, and we are unpacking a paradigm shift that is fundamentally rewiring the technology sector right in front of us.
We really are. And we have a massive stack of sources to guide you through this today.
Yeah, it's anchored by this really fascinating editorial from the AI World Journal. It's titled, The Future of AI Isn't in Massive Data Centers, It's on Your Device.
And alongside that, we're tracking a whole flurry of current industry news headlines, stuff regarding data centers, grid deliverability challenges, and just the rapidly shifting economics of the tech world.
Because, the overarching narrative over the last few years has been this brutal arms race, right? Just building bigger, faster, thirstier data centers.
Oh, absolutely. Trillions of dollars have been committed to that infrastructure.
Right. But the reality taking shape beneath the surface of those headlines points in the exact opposite direction. So let's unpack this.
Let's do it.
To really understand where AI is going, we need to take a look at where computing has been. Because, we're basically watching history repeat itself in fast forward.
We really are. To understand the gravity of this transition, you have to look back at the very first computing revolution.
The 1960s and 70s, right?
Exactly. Back then, the digital architecture looked eerily similar to the AI landscape we've seen recently.
How so?
Well, everything revolved around centralized mainframe computers. They took up entire rooms, they required specialized engineers in white coats to operate, and they lived in these heavily air-conditioned vaults.
And nobody actually owned a computer.
Mm-hmm.
A bank or a university didn't buy a computer. They effectively just rented computing time from the central mainframe.
Right. The mainframe was the undisputed gravitational center of the tech universe. Owning one was prohibitively expensive.
And physically impossible for the average person.
Exactly. But then the personal computer arrived and entirely decentralized that power structure.
It took computing out of those vaults and put it directly onto people's desks.
And the business fallout from that transition is what we really need to focus on.
Right, because the companies that failed to recognize that shift, like IBM, who were, the undisputed kings of the mainframe era, they lost their absolute dominance.
They were completely outmaneuvered. Upstarts like Apple and Microsoft championed the idea that computing should be local, it should be personal, and decentralized.
So right now, we are all basically just renting time on the tech giant supercomputers.
We are.
We are living in the AI mainframe era.
Right.
When you use tools like the early iterations of GPT-3 or GPT-4, you are just pinging a distant mainframe.
Those early cloud-based foundation models are the modern equivalent of the IBM mainframe.
Right.
They were so massive, they required gigabytes of memory and enormous cloud infrastructure just to load their parameters.
Just to load them, not even to answer a question.
Right, let alone actually operate and generate a response.
But wait. This brings up a huge logistics problem.
Yeah.
The historical parallel makes perfect sense on paper. But how do you physically take a massive cloud model that requires football fields of advanced GPUs and stuff it into a smartphone?
It sounds impossible, right?
Yeah. The physics don't seem to make sense. You simply cannot fit a data center in a laptop.
You can't. And that is where a series of brilliant engineering breakthroughs from the last few years come into play. We are witnessing the rapid, deliberate shrinkage of these models.
A shrink ray for AI.
Exactly. Running an advanced AI locally on your own hardware was pure fantasy just a short time ago, but today the landscape is flooded with highly optimized open source models.
Yeah, our sources specifically point to models like Meta's Llama 3, Microsoft's Phi 3, and Google's Gemma.
And those models are already running incredibly efficiently on consumer hardware. Engineers are achieving this through a few specific techniques.
So how does this shrink ray actually work?
Well, the first technique, and perhaps the most foundational, is called model quantization.
Okay, let's break down quantization for the listener because that sounds incredibly dense.
It does. So an AI model is essentially a massive collection of mathematical values.
The weights. Yeah.
Exactly, the weights, which dictate how the network processes information. Traditionally, these weights are stored as 16-bit floating point numbers.
Meaning they have a lot of decimal places.
Right. They have incredible precision, which means they take up a massive amount of digital space. Quantization simply reduces the precision of those numbers.
So it chops off the extra decimal.
Basically, yeah. It compresses the math from 16-bit down to 8-bit, or sometimes even aggressively down to 4-bit. And by doing this, you drastically cut the amount of RAM the model needs just to exist on the device.
Okay, here's where it gets really interesting. Because if I take a high-resolution digital photograph and I compress it to save space on my hard drive, it gets blurry, right?
Oh, for sure. It gets pixelated.
The quality noticeably drops. So if engineers are quantizing these AI models and chopping 16-bit math down to 4-bit math, aren't they essentially making the AI dumber? Doesn't the reasoning get blurry?
That is a fantastic analogy, and it is exactly what researchers initially feared would happen.
But it didn't.
Not really, no, because an AI model isn't storing a visual picture, it's storing probabilities and patterns. Neural networks operate on directional weights.
Okay, what does that mean in plain English?
Well, if a mathematical weight is pointing strongly toward a certain conclusion, the difference between an incredibly precise 16-bit decimal, say, 0.9876, and a rounded 4-bit number like 0.9 often doesn't change the final decision the network makes.
Oh, wow. So the mathematical shape of the data remains intact.
Exactly. It's less like compressing a photograph until it's pixelated and more like recognizing your best friend's face in a slightly grainy photo.
Right. You don't need a 4K resolution image to know it's them because you recognize the core pattern.
Precisely. The neural network remains remarkably resilient, allowing a quantized model to draft flawless emails or summarize complex corporate documents entirely locally.
Okay, making the file size smaller is one thing, but running a neural network still requires serious juice.
It does.
I mean, my phone battery cries if I play a high-end mobile game for an hour. How is a laptop supposed to run billions of calculations locally without melting the battery?
That brings us to the second major breakthrough, architectural innovation.
Which is what?
Specifically, a technique called mixture of experts, or MOE.
Mixture of experts. Okay, explain that one.
Well, instead of training one massive monolithic neural network where every single parameter has to fire up and use power for every single question you ask, MOE breaks the model down into highly specialized subnetworks.
The experts.
Right, the experts.
So it's basically dividing the labor.
Exactly like a massive hospital. I mean, you wouldn't page the entire staff of 500 doctors to look at a single X-ray.
No, you just page the radiologist.
Exactly. When you give an MOE model a prompt, a routing mechanism analyzes your request and only activates the tiny portion of the neural network that is actually qualified to handle that specific task.
And the rest of the model.
It stays entirely dormant. This saves incredible amounts of compute power and memory bandwidth.
So if I ask it to write a Python script, it leaves the creative writing expert asleep and only wakes up the coding expert.
You nailed it. That solves the software side of the power issue.
Okay, so what about the hardware side?
The hardware side is being solved by specialized silicon. We are talking about neural processing units, or NPUs.
NPUs, right? Because we used to just have CPUs and GPUs.
Exactly. Historically, consumer computing tasks were split. You had CPUs for general, step-by-step logic, and GPUs for parallel tasks like rendering graphics in a video game.
But AI math is different.
Very different. Specifically, it relies on matrix multiplication. So hardware manufacturers like Apple with their Neural Engine and Qualcomm with their Hexagon processors, they started building dedicated physical lanes directly onto the silicon.
And these are the NPUs.
Yes, these NPUs are designed strictly to run AI workloads. Because they are purpose-built for one specific type of math, they can process it at a mere fraction of the power cost of a standard CPU or GPU.
So let me recap this. Through quantization, we shrink the file size. Through mixture of experts, we optimize the software efficiency.
And through NPUs, we have hyper-efficient physical hardware.
The physics problem is solved.
Yeah.
The AI physically fits on the device. But, that brings us to the next vital question for you, the listener.
Why should you care?
Exactly. Why should you care? If the cloud models work perfectly fine right now, why go through all this trouble to move it to the edge?
Well, moving AI to the local device isn't just some cool party trick. It fundamentally transforms the utility of the technology in ways the cloud simply cannot match.
The sources outline 5 distinct advantages for this, right?
They do.
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society Circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
And the first one is unbreakable privacy.
Which is massive for enterprise.
Yeah.
I mean, right now, if I ask a cloud AI to summarize a confidential corporate merger document, or if I upload a private medical photo to ask an AI for an analysis,
That data has to physically leave your device?
right, it travels across the open internet, and it sits, at least temporarily, on a stranger's server.
And look, for asking for a pancake recipe, maybe that's fine. But for the healthcare sector, law firms, defense contractors, that is an unacceptable security risk.
Of course.
On-device AI ensures your most sensitive data never actually leaves your physical possession. The analysis happens entirely locally on the NPU.
So there are no external servers involved at all.
None. Which clears the biggest hurdle for enterprise adoption.
That makes total sense. Now, the second advantage listed in our sources is zero latency.
Yes. Cloud AI is ultimately bound by 2 physical bottlenecks. First, the speed and reliability of your Wi-Fi connection.
Which we all know can be terrible.
Right. And second, the literal speed of light. It takes time for your prompt to travel out to a data center in Virginia, get processed, and travel all the way back.
Even if it's just a second, you feel it.
Exactly. Local AI, on the other hand, operates at the speed of electrons moving through silicon millimeters apart.
It's basically instantaneous.
Instantaneous.
Yeah.
And that speed opens up entirely new applications. Think about real-time, live translation of a foreign language directly in your ear during a conversation.
Oh, wow. Yeah, you couldn't do that if you had to wait for the cloud.
Right. Or AI-assisted photography that analyzes and adjusts the depth of field in your smartphone's viewfinder before you even press the shutter button.
You literally cannot afford to wait half a second for the cloud to process that. It has to happen locally.
Exactly. Which flows naturally into the third advantage, true offline functionality.
Right, because your super smart cloud AI is completely useless if you are on an airplane in airplane mode.
Or riding a subway, or out in a rural area doing field research.
Local AI works anywhere, anytime, completely independent of a cell tower.
It makes the technology reliable enough to be considered critical infrastructure for a worker rather than just, a neat web tool.
Okay, so that's privacy, latency, and offline access. The fourth advantage changes the financial landscape entirely. The death of the token tax.
Yeah, if we connect this to the bigger picture, this is where the macroeconomic disruption really hits.
Because right now, every time you or a business interacts with a cloud-based AI, you are paying a toll.
Always. It might be bundled into a monthly subscription, or it might be an API fee where a developer pays a fraction of a cent per word generated.
But those fractions of a cent add up fast.
Mm-hmm.
I mean, if a company has 10,000 employees generating reports all day, that API bill becomes astronomical.
It really does. But when a business deploys a local open source model across its entire fleet of employee laptops, the marginal cost of inference, the cost of generating an answer, drops to virtually zero.
Wow. You pay for the hardware one time upfront, and you never pay a cloud provider an API fee for the words it generates ever again.
Exactly. It breaks the monopoly of the major cloud providers who are currently acting as the toll collectors of the intelligence age.
That radically democratizes AI for startups, right?
Yep. Oh, completely. Especially for developers in emerging markets where paying hefty API bills in US dollars just isn't feasible.
Okay, the fifth and final advantage really stood out in the sources. Environmental efficiency. The New York Times article in our stack actually leads with the headline, A solution to AI's growing power demand. Homes.
It sounds super counterintuitive, right? Even how much power AI uses.
Yeah, you'd think millions of laptops running AI would use more power, not less.
But we have to separate training from running. Training a massive frontier model requires staggering amounts of energy. But when it comes to running the models, which is called inference, using smaller, optimized models on personal devices is vastly more energy efficient.
Because the device is already turned on and sitting on our desks anyway.
Exactly. Routing every mundane request, like just summarizing a paragraph, through a power-hungry server farm is terribly inefficient for the global power grid.
So, unbreakable privacy, zero latency, offline access, no token tax, and better environmental efficiency. I mean, the case for local AI seems absolutely airtight.
It's very compelling.
But, we have to address the reality check here. If on-device AI is the definitive future, why is our newswire today flooded with stories about tech giants still pouring trillions into massive infrastructure?
That's the million-dollar question. The shift to the edge, it doesn't mean data centers are just going extinct. The AI World Journal editorial frames this ecosystem as the hybrid reality.
The hybrid reality.
Yeah, the prevailing rule of thumb is this: train in the cloud, infer at the edge.
Okay, so the data centers create the massive frontier models. They act as the teachers.
Yes, the gigawatt-scale GPU clusters are absolutely essential for the heavy lifting. They train the cutting-edge models, and they generate high-quality synthetic data.
And then what?
Then engineers use that data to train the smaller, highly efficient student models, like the Llama 3s and Phi 3s that actually get downloaded to your phone.
Okay, so what does this all mean? Let me offer an analogy to see if we're putting this together correctly for the listener.
Go for it.
It sounds like the massive data centers are the heavy machinery factories. They are consuming the raw materials and immense power to stamp out the product, which is the intelligence itself.
Right.
But our phones, our laptops, our smart glasses, they are the nimble local retail stores. That's where the actual interaction with the customer happens.
That is a perfect visualization. The factory builds the intelligence, the storefront delivers it. But, the newswire is showing us that building those factories is creating immense friction right now.
Oh, major friction. Let's look at some of these headlines. We have a report from ICF warning that U.S. electricity demand could jump by an incredible 39% by 2035.
Just due to these data centers.
Yeah, and they specifically note that the biggest challenge isn't even just generating the power, it's grid deliverability.
Which is a huge logistical nightmare. You can build a massive wind farm or solar array, but if you don't have the high voltage transmission lines to physically deliver that power to the data center campus, the energy is useless.
And we are seeing that gridlock happen on a state level too.
We really are.
There's another report out of Texas noting that the future of their local AI infrastructure is hinging almost entirely on policy reform and transmission constraints.
Right. Regulators are trying to figure out which of these massive proposed gigawatt-scale campuses can actually move from just being a press release to a functioning facility.
It's incredibly complex,
Yeah.
and the financial logistics are just as messy as the physical grid.
Oh, absolutely. There's a headline today about Oracle fighting a legal battle in Wisconsin right now.
What's the core of that suit? We're just reporting the facts here, obviously, but what are they testing?
They're testing how states hedge the financial risks of these massive AI power projects.
Oh, it's essentially exploring whether state regulators can require massive financial guarantees from tech companies up front.
Exactly, because what if the AI bubble bursts, right? Or what if a data center project goes bankrupt in 5 years?
Then the local taxpayers don't want to be left paying the bill for all the new power plants that were built to support them.
Exactly. So the newswire is painting a very clear picture here. Sustaining the exponential growth of cloud-based AI infrastructure is becoming physically, financially, and politically constrained.
And this friction is exactly what is accelerating the push toward edge computing.
Moving the intelligence out of the factory and into the retail store.
Which brings us to the ultimate conclusion of this deep dive. The sources define this upcoming era as edge intelligence. We are moving toward ubiquitous ambient computing.
Yes. Your everyday devices will no longer be what the industry calls dumb terminals.
Dumb terminals.
Yeah, a dumb terminal is just a screen that relies on the smart cloud to do all the thinking. But as these localized models become more capable, your devices will become intelligent, independently reasoning entities.
The sources mention autonomous vehicles, right?
Uh-huh.
I mean, a car driving at 70 miles an hour has to make split-second decisions based on constantly changing physical environments.
Exactly. It cannot wait for a server in another state to tell it to hit the brakes.
Right. Or an industrial robot on a manufacturing line, inspecting microscopic flaws in real time.
Or even a pair of smart glasses that overlays digital information seamlessly onto the physical world as you walk down the street.
All of these advanced use cases require the AI to live directly on the device.
Right. Perceiving its environment, reasoning through complex variables, and acting completely independent of any cloud connection.
This is a profound shift in how we interact with technology. I mean, we've spent this entire deep dive talking about the technical and economic mechanisms driving this transition. But as we wrap up, I want to leave you, the listener, with a final thought to mull over.
It's a big one.
It is. We started by picturing those massive, windowless, blinking data centers far away. And we established that the real intelligence revolution is actually coming home to your living room.
The future of intelligence is incredibly intimate.
And that raises a fascinating psychological question. If every single device around us, our cars, our smart glasses, our laptops, our household appliances, if they soon possess the ability to perceive their environment, reason through complex problems, and act completely offline and independently,
Yeah.
how will that change our psychological relationship with everyday objects?
Oh, wow. It really forces us to reevaluate what a piece of hardware actually is.
Exactly. When our possessions are no longer just passive tools waiting for a button to be pressed, but are actually active, thinking entities, the whole dynamic shifts.
It really does.
I mean, when a car isn't just a motor and wheels, but something that perceives the rain, anticipates your schedule, and reasons through traffic completely independently, does it start to feel more like an autonomous companion than a machine?
I guess we are about to find out what happens when the things we own start thinking for themselves.
We really are. When the intelligence finally leaves that concrete fortress and moves into the objects we touch every day, our entire relationship with the physical world is going to feel very different. Thank you so much for joining us on this deep dive. We'll catch you next time.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.